this is another example. If x square y prime prime equals to xy prime plus y equals to 0, show that x square y raised to power n plus 2 open bracket 2n plus 1 xy raised to power n plus 1 plus n square plus 1 y raised to power n. Now we have to show that this is equal to this. What we need to know, is that if u equals to y, un will equals to yn. If u equals to y prime, my un will equals to yn plus 1, and if u equals to y prime prime, un will equals to yn plus 2. So we need to know all this. Now the question is x square y prime prime plus x y prime plus y equals to 0. So we have to show that this equation is equal to this. Now let's separate it, do it separately. My n1, I will make it to equals to x square y prime prime. That is my w1. Now from here, I can easily identify my u to equals to y prime prime, our v equals to x square. So which un to give us yn plus 2, then v1 to give us 2x, v2 to give us 2. This is our w1. Now we remember wn1 now equals to the formula u raised to power n v plus n minus 1 v1 plus n minus 1 u raised to power n minus 2 v2 over 2 factorial. So we stopped here because our v stopped at 2. Now my un equals to yn plus 2 dot my v equals to x square plus n. Now u raised to power n minus 1 means that we should minus 1 from this power that we have here. So we have yn plus 1. My v1 equals to 2x plus n minus 1. Now we should minus 2 from here. So we have yn alone. Dot my v2 is 2 over 2. So wn1 will equals to yn plus 2 dot x square plus n yn plus 1 dot 2x plus n, this one cancel this one, n minus 1 yn. That's what we have here. Now I will take this w2 to equals to xy prime. Now from here we can have my u to equals to yn y prime, then my v equals to x, un equals to yn plus 1, then v1 equals to 1. So u2n now equals to un u raised to power n v plus n u raised to power n minus 1 v1. So we stopped here because of v1. So my un is y raised to power n plus 1 dot v, which is x, plus n. So it's a minus 1 from each. So you have yn dot 1. So this is my w1. Then we have wn2. Now w3 to equals to just y. So here we can see that it's only u that we have. So un will equals to yn. So wn3 will equals to un v. So where our v equals to 1. So it will be just un that you're going to have here. So v is, in the first video we said v equals to is raised to power 0. So in this case, raised to power 0, so it's the same thing as 1. So our wn3 here is this. So this is what we have for the third one. For the second one, we have this. For the first one, we have this. So what we're going to do is that we are going to combine everything together. So my yn now will equals to wn1 plus wn2 plus wn3. So for wn1, we have yn plus 2 dot x square plus yn plus 1 dot 2x plus n minus 1 yn plus w2. We have yn plus 1 dot x plus n yn w3 plus yn. So everything equals to 0. Now, in this aspect, we are using the power to factorize. It is the power that we are using to factorize. So as you can see, we have n plus 1 here. There is another n plus 1 here. Do you get? So if I bring those two together, so I will have n plus 1 dot 2x plus yn plus 1 dot x plus n minus 1 yn plus yn plus yn equals to 0. So we can see that we n plus 1 dot x square doesn't have any other it doesn't have any other that have n plus 2. So we have n plus 1 is common, x is also common. So we're going to have 2n, because we've taken this out, we've taken x out, so it will mean n and 2. So we have 2n plus, in this one we have 1. So we have x yn plus 1 plus, what is common here? Yn is common. So we're going to have n minus 1 plus n plus 1 yn equals to 0. So if we continue, we have yn plus 2 dot x square plus 2n plus 1 xyn plus 1 plus, if I open brackets, I will have n square minus n plus 1 yn equals to 0. This one cancel this one. So we have n plus 2 dot x square plus 2n plus 1 yn plus 1 plus n square plus 1 yn equals to 0. So as we can see, the question is x squared plus y prime prime plus x. We have to show this equals to this. So this is what we have here. It's the same thing as what we have here. So thank you. Now the next example 4 now. So we have 1 plus x squared y prime prime plus 2xy prime minus 5y equals to 0. So if we are to solve this, now in this case now, I will not do any separation. I will just solve it straight. Now I can see that from this, let me rewrite again. So we have yn x squared y prime prime plus 2xy prime minus 5y equals to 0. From here, my u equals to y prime prime with un we equals to yn plus 2. So we have v equals to 1 plus x squared. Now v1 will give us 2x, v2 will give us 2. This is from here. From here now, my u equals to y prime. Then un will give me yn plus 1. My v equals to 2x. v1 give me 2. In this case now, I can call this my u equals to y. Then my un equals to yn. V equals to minus 5. Then v1 equals to 1 is 0. So if I differentiate it, I will have 0. Now the formula, we are using this formula yn equals to unv dot plus n un minus 1 v1 plus n minus 1 un minus 2 v2, because the ISV that we have here is 2. Now for this first one, we're going to use this formula. For this second one, we will stop here. For the third one, we're going to stop. So let's continue. So v1 is 0, so we don't need to write that. Now for the first one here, what is our un? My un is what? My un is yn plus 2 dot v is 1 plus x square plus my, this is n, then we should minus 1 from it, so we have n plus 1 dot 2x, then plus n minus 1, we should minus 2. If you minus 2, we just have only yn dot 2 over 2 factorial. So over 2 factorial. Now we are done with this part. Plus, so we're going to start again. What is our un here? So my un is yn plus 1. My v is 2x plus our n. We should minus 1 from it. So we're going to have yn dot, what's our v1? We have 2. So we are done with this. Plus, what's our un here? My un is yn. What is our v? Our v is minus 5. So we're going to have yn plus 2, 1 plus x squared plus n yn plus 1 dot 2x plus, then I'm bringing this here. So we have yn plus 1 dot 2x, this one. So I brought it here. Now this one cancels, so this one. So we have n minus 1 yn plus n dot 2 minus, this one become minus now, minus n. So we can see that we're going to have 2 1 plus x squared plus, now this is common, so we have this here, from here and here, between here and here we have yn plus 1 yn plus 1 2x 2x, so it's going to remain just n, it remains just n. Now this one be plus 1, so we have 2x n plus 1 plus yn is common all through, so we're going to have n, let's open the bracket, so n squared minus n, so it remains plus n here. Then we have, sorry, this is minus 5 yn, this is minus 5 yn, so we have 2n. We've taken this out, so it remains 2n here, so we have 2n minus 5. So we can rewrite it yn, so we can rewrite it as yn plus 2 1 plus x squared plus these two should stay forward, n plus 1 x yn plus 1 plus n squared plus n minus 5 yn. So this is our answer. Everything, or we can say everything, is equal to 0. Also, we can bring this one to be at the front to have 1 plus x squared yn plus 2 plus 2n plus 1 x y n plus 1 plus n square plus n minus 5 y n plus. Yes, so thank you for watching the video. Please follow up, like, and subscribe.